Welcome to What's in Your Data.
Brought to you by Melissa. Howdy, my name is Daniel Lee and I'm the Chief Data Wrangler at Melissa.
My name is Anna Chong and I'm a software engineer team lead here at Melissa.
Hey, so have you been to zip code 501?
No, I don't think that's a real zip code. I think zip codes are 5 digits.
But my Excel says 501.
I think it might be missing.
Oh, you know what? You're right. Missing leading zeros.
Classic
I think
Excel.
it should be, yeah, when you copy data from system 1 to system 2.
Yeah.
It sometimes loses the data, validity. I mean, you lose data.
Yeah,
Something transformed, something went wrong.
Yeah.
I think it's supposed to be 00501, which is zip code fact. It's the lowest zip code possible assigned to the IRS.
Oh yeah.
In Holtzville, New York.
I remember we've had this
discussion
before. Yes.
Yeah. Zip code facts.
Yes.
But it's supposed to be 00501. But on Excel, when you paste in a number, it thinks it's a number. So
it chops up.
It just says, you mean 501?
Yeah,
so it took out all the leading zeros.
That happens.
Yeah.
Yeah.
So, especially when you take data, when you export data from one system and you import it to a second system, if you don't carry the right data type, you lose data integrity.
Yep.
Yeah.
Yeah.
So
well, that's not good.
Well, that's what we're going to talk about today.
All right.
Why data types matter.
Yeah. So I guess, in order to talk about why it matters, we should probably talk about the different types, right? So should I go through and just kind of list out the different types and we can talk about what each of them are all about?
Well, what are data types?
That's a loaded question.
It really is, and and I'm trying to think about it in a way that we can all relate to.
Okay.
And I think about taking food to go.
Okay, so there's a story behind this, folks. It seems.
When you go to a restaurant and you take food to go, you ask for containers.
Okay. Yes.
And you want the right container for the right food.
True. You don't want soup in a little box.
In a rice box, right?
Yeah.
Like so I'm sure you've taken takeout before, and soup goes usually in a soup container with a lid that's hopefully secure.
Yeah. Sometimes there's a little leak, but
But rice,
better than like a paper
rice
plate,
or noodles can go in a different kind of container.
Yeah.
You got paper containers. You got waxed coating, styrofoam. What else? Yeah. Different types of containers.
Yeah.
And different sizes.
Yeah.
Right? I mean, you have a little 1 cup portion. You don't need a 10 cup tray, aluminum tray.
Sometimes they do that though.
Really?
Yeah. Sometimes you go to a restaurant, you have leftovers, right? And you're like, hey, can I get a box for my...
Like a little one?
Yeah, like a little one. But then they give you like this big giant box and you're like, what am I...
That is when you assign the wrong data type.
Yeah. I can see that. Yeah.
Yeah. Or moving boxes. Okay.
Sure. Yeah.
I think we've all moved, and when you move, you want to pack it full, but not too big that you can't carry, and not too small that doesn't fit your thing. It has to be the right box for the right item.
Right.
With the right padding and wiggle room and such. Right.
Yeah. Sure.
So all these concepts of the right container for the right item, that's the exact same thing for why data types matter.
Okay. Well, should we then talk about some data types and how they fit into these containers?
So data types are basically data containers.
Yeah. Okay.
Yeah.
Well, let's talk about something very basic, right? We're talking about nulls. Nulls, empty strings, and something that actually has a value.
Nulls?
Nulls. Nulls.
Nulls. NULL.
Yes.
Okay. All right. Let's think about this from a box perspective.
Okay.
Okay. So there's null. There's the literal word null.
Quotes. Yeah.
And an empty string.
Okay.
So when we say the literal word null, it could be in any word. It could be the word Daniel, the word Anna, the word null, NULL. An empty string is okay. So let's think about it this way. You have a box. It's just an empty box. Nothing's in there. It's a vacuum. That's like null. There's nothing there.
Okay.
Okay. You open up the box and you let some air in.
Okay.
It's just air. There's nothing else in there. To us, we say it's nothing. It's just atmosphere.
Yeah.
That empty air is like an empty string.
Okay.
Now you actually put stuff in there to fill up the box. That's when you're putting actual characters, values in it.
Okay.
So those are three different states the box could have been in. The box that contained this
Yeah.
data container, right?
Yeah.
So null is the absence of value. An empty space is an actual value. It's just an empty space. Not literally a space bar, but just empty.
It's like there, but not there.
Like, you know it's a value, it's a value of nothing.
Yes.
Versus null is you don't know if there's a value.
Right. Like the void.
Yeah, and then if you put a space bar in or like a character, then there's real stuff.
Oh, null is like Schrodinger's cat.
You don't know.
You don't know unless you open it, and then if you open it, I guess an error goes in, and then it is empty string at that point.
From a data container perspective, it's void.
Yeah.
Yeah, so there's three states. Yeah,
Okay.
so when you think about it, that's how you think about like different null versus empty string.
Okay.
And some transitions when you take from a database to another database, in one it could be a proper null, like void, like you don't count it.
Yeah.
But when they translate it over, they put the word null in, like NULL.
Yeah.
So now it's become something.
Sure.
So it's become something of 4 characters, the letter NULL, and now it's something, but really it wasn't.
So again, kind of going back to the system 1, system 2 data transfers.
Right. That can mess up if you don't declare your data types correctly.
Sure. Okay.
Yeah.
Okay. So we talked about nulls and the absence of empty and something. So then let's take some simple step from there and let's talk about strings, right?
Okay.
So we're talking about varchar and then varchar. Sorry, varchar and char. The very simple, just a hello, for example, right? So what takeout box analogy do you have for hello?
Takeout box. I think more like okay. So first of all, char. Also, some people say car because the original word was character.
Okay.
And then varchar or varchar means variable character.
Yep. Okay.
Okay. So those two, I think about it like, so variable means it's variable. It takes up the amount of space you actually need.
Yeah.
And character is fixed. The space is always there. You either fill it or you don't. So the easiest way to think about that is like character or char is like a parking lot.
Okay.
You have 10 parking spaces. It's assigned. It's there.
Yeah.
You fill it with cars or not, it will always be there.
Yeah. True.
So it's fixed. And so most systems will pad it with spaces.
Okay.
So if you put the word hello in, HELLO, that takes 5 characters.
Yeah.
You have 5 remaining. If you read it back out, it's HELLO space.
If it was char 10.
If it was char 10.
Yeah. Okay.
But variable, and that's there's pros and cons, and basically there's some optimizations you can do with a fixed, like that's how much space you need. You'll always reserve that space.
Yeah.
But with variable character or varchar, it's like a queue, like a theme park, amusement park line.
Okay.
You fill up the line, and then they can close the line behind you, or they can extend the line. They wrap around. They can expand and contract.
Okay. Yeah.
As needed for the amount of characters you put in, up to the specified amount.
Okay. Yeah.
So you've seen those lines, those queue lines, right?
Yeah.
They snake around.
Yeah.
But if there's only like 2 people in line, they'll let you shortcut it, or they'll move the end closer.
Sure.
Yeah. So
Okay.
that's one way to think about that.
Okay. I guess how would you handle, I guess, what are some systems that you know of that are benefit of using char versus varchar?
Okay.
Because it seems like it would take up space,
Sure.
like unused space. So I guess what would be the benefit of that?
Okay. So varchar is safe space, right? You say everything can be up to 10 characters long.
Yeah.
But if I only take 5, then just use 5.
Yeah.
But char 10 always takes up 10.
Yeah.
So if you had, and you think about this now it's getting a little specific, technical, but if you have 10 boxes of 10, then you know you have 100 total. And if you know you want to seek to the 3rd record, you can jump to position 30.
Okay.
So you skip 10, you skip 20, you go to 30, like 29, 30, and start reading from there
Okay.
for the next 10 spaces.
To get that positional point.
Yeah, you can jump to position because you know you can skip exactly 20 spaces.
Makes sense.
To get to the 3rd record.
Okay.
Always. But with variable, you're not sure. So yeah, you use indexes and use other techniques.
Sure.
But
Gotcha.
variable, you have to skip a variable amount of characters.
Which you don't know. It could every record could be different.
Right.
Yeah.
So it's space versus speed.
Okay.
Kind of.
Okay.
Kind of.
There's another type of string data type that we should talk about, which is now varchar versus nvarchar.
Nvarchar.
Yes.
Oh, okay. Now again, varchar and char, same concept, right? Nvarchar, nchar, so we don't have to cover that. But let's talk about the N.
Yes.
The N stands for national. So it stands for national language support.
Yes.
And really, for us, international.
Sure.
It's like, varchar is like a basic typewriter, like an English typewriter. It's all the letters on there. But if you want to go beyond that, you have other, they call them code pages, or Unicode, or you've heard of these things,
Yes.
UTF-8, UTF-16, these are encoding ways. Basically, it's how do I store this character? And here we can see that there's hello in English, and then there's hello in Korean.
Yes.
There's only two, what do you call them, letters or words?
Characters.
Characters.
Sure.
Two characters in Korean, they each take up 2 spaces.
Even though they are one
Character. But they now take up 2 spaces.
Yes.
Because that's required to store all these additional characters for all the international languages. So hello in English takes 5 characters, and hello in Korean takes up 4, 2 for each character.
Gotcha. Okay.
Yeah. So nvarchar, nchar is basically a way to store using 2-to-1 ratio, the size
Okay.
of characters, and anything outside of the ASCII.
Gotcha. Okay. Yeah. So we want to make sure if you need to store Latin versus non-Latin characters to know which one to use. Because if you don't, then you could lose, again, with the data, right? From one system to the other, you could lose that information, and it will end up being like question marks or something.
Exactly. If your original data set was nvarchar, and you try to force it into varchar, the data gets jumbled up.
It's not going to work.
You just lose it.
Yeah.
Now, you can't go the other way. You can go from varchar to nvarchar.
Okay.
It's the same. It's just you take up more space.
Why? Yeah. Like, why take more space for something you don't need it for?
It's like getting an aluminum tray to store a little 1 cup of rice.
Yeah.
You're to go.
Yes.
Yeah.
Okay. All right. Well, moving on from letters and characters, let's talk about numbers.
This was the classic 501 problem.
Yes, it was. Yeah. So let's talk about it. I mean, we have varying amounts of varying types for numbers, digits, right? We're talking about tiny int, small int, and then big int. So I guess let's talk about each of those.
So zip codes with leading zeros would probably be better stored as characters. So you can store the number 0 first, 00501.
So you don't lose the leading.
You don't lose the leading, because if you convert that to a number, it just looks like 501.
Yes.
So integers are when you deal with actual numbers and not words, or like something that requires leading zeros, basically.
Sure. Okay.
Yeah. Now, why are there different types? Well, because it's back to the container size. Let's talk about baking. If you're doing measuring cups, each of this is like a measuring cup.
Okay.
You said tiny int, that can measure 1 byte's worth.
Okay.
And up to a maximum of 1 byte's worth, 2 to the 8th.
Okay.
Unsigned, signed, that means positives only, or positive and negative.
Yeah.
You can do the math.
Yeah.
But basically, it's 1 byte's worth. The next one is small int. That's 2 bytes worth. The integer is 4 bytes worth. Powers of 2 here.
Yes.
And then big int, which is 8 bytes worth.
Yeah.
Each one is just a much bigger measuring cup.
Sure.
Can you put everything in big int?
Sure.
Yeah.
Is it excessive?
You're using 8 bytes to store the number 1
Yeah.
over and over and over. So by knowing your data, you can use the right integer type to store it, and also helps for data validation. Like a tiny int goes up to a certain range, depending on if it's signed or unsigned. If you know that your numbers should be within that range, you use a tiny int.
Yeah.
Then if someone tries to put in a number higher than that, your system will throw an error.
Right.
And say, hey, are you sure? Like this overflows. You can't fit it. So you're like, oh yeah, that was an error. At some point, you can expand. You can go bigger.
Sure.
Yeah.
Interesting. Okay.
Yeah. And then big int is very big.
How big is it?
It goes up to, using 8 bytes,
Okay.
Okay, and I'm using, I think, signed, so that means positive and negative.
Okay.
It goes up to 9 quintillion.
What is that? How many zeros is that?
That's 18 zeros.
Okay.
So yeah, so number 9 followed by 18 zeros. It's pretty big.
I don't think a regular calculator can even store that number. How do you even?
Unless you have a calculator that can deal with with that many bytes. But so I read somewhere just like they did a little modeling. They're like scientists predict how many grains of sand there are in the world, and it's less than 9 quintillion.
Oh,
So
interesting.
you can assign a number to each grain of sand in the world, and you can fill up, not even fill up a big int.
Interesting.
Yeah, so it's pretty big. Yeah, for now, and you know you use the right data type for how much space you actually need.
So basically, whoever thought of big int has thought about maybe assigning a record for each grain of sand.
Maybe that was his project, and he hit a limit with integers.
Maybe he's like, no, I need more.
I ran out.
Okay. Okay, now let's talk about something a little bit more precise. Something a little bit more, something you could be a little bit more granular with. We're talking decimals and floats.
Sand, grain, granular.
Yeah, exactly.
Decimals and floats.
Oh,
So
there we go.
let me see. Decimals would be more precise than float.
Okay.
Float is approximate. Decimal is exact.
Okay.
Float could be faster, but decimals, again, are exact.
What do you mean by faster?
Okay, so floats use something they call binary math,
Okay.
which is math based on powers of 2.
Okay.
And decimals use math based on powers of 10.
Okay.
So with decimals, you store the number part, and then you store how many decimals you want to store, and everything, and all that takes space.
Yeah, sure.
But with float, you store it as powers of 2, using bits. Bits are in binary, and so you approximate. So here's a way to think about that. So we can get technical, and we can see how this is a classic example. If you take a float 0.1,
Okay.
and you add float 0.2,
Okay.
what do you think the answer should be?
0.3.
0.3. But that's decimal calculation.
Okay.
The float calculation will come out to be 0.3 0 0 0 0 0 0 0 0 0 0 0 0
Okay.
0 0 0 4.
4?
Yeah, it's rounding.
I was like, where'd that 4 come from?
There's 15 zeros
Okay.
in between the 3 and the 4. So it's like 0.3, a bunch of zeros, and a 4.
Interesting. Okay.
Now, usually with float, it's good enough to 7 decimal places. So if you chop it off, it is 0.30000.
Okay.
But certain calculations can run into rounding errors
Sure.
just because of the way the math works.
Oh, okay.
And the way that I think about it is like, 1/3.
Yeah.
If you take 1/3 of something in your head, you know exactly how much that is. It's 3 pieces make up a whole.
Yeah.
But if you want to write that down on a piece of paper, what would you write?
Like 1/3, 1/3.
Uh-huh.
Like as a math.
As a number.
As a number.
As a decimal.
0.3.
Okay, 0.3. Now take,
I mean, 333.
sure, 333,
Repeating.
Repeating, okay. And multiply that by 3.
0.9999.
Yeah.
Repeating.
Yeah. And now we get into some nuances of algebra. We can talk about that. But 0.3, which is the approximation of 1/3,
Yes.
times 3 is 0.9,
Yeah.
which is the approximation of 1.
1. Okay.
That's so 0.3 is like a float, and 1/3 is like a decimal.
Okay.
One side is approximate, and the other side is exact.
That's confusing because you're saying 1/3 is a decimal.
Right,
But
right.
1/3 is actually a
it's
fraction. Yeah.
Yeah. But I'm just saying the level of accuracy.
Sure. Yeah.
So it's hard to represent the concept of a fraction 1/3
yeah.
as a decimal number.
Right. Yes.
Until you get to repeating numbers and you get into algebra.
Okay. Yeah. And that's how your high school class was born.
Yeah, that's one way to think about it.
Oh, okay. Well, fascinating.
Hey, do you know what time is it?
I don't know. It depends. What kind of time are you asking for? Oh,
Oh.
that was quick, wasn't I?
Yes.
Because I know what we're talking about next. My favorite.
Your
Not
favorite?
really. Not really.
Do you want to talk about it?
No. I'm gonna let you talk about your, because I think you have a story for this one.
Well, they time. So I still don't know what time is it, but apparently
I don't know.
on the screen here we have, and I'm going to read it all out here.
Yeah.
2026 0101. So that's January 1st.
Yep.
At 13:30. So that's 1:30 p.m. 00 seconds. Point 1, 2, 3, 4, 5, 6, 7. Little seconds.
Sure.
Like not milliseconds, but even smaller than that.
Sure. Yeah.
And then I see a -08:00.
Okay.
So that's like minus 8 hours.
Yes.
That sounds like a time zone.
Yeah.
So all together, all of that in Microsoft SQL Server words, they call it a datetime offset.
Yes.
A date time with an offset.
Yes. Which is the time zone.
The time zone, yeah. So you can be +1, -1, +2, -2, depending on where you are in time zone relative to GMT.
Yes.
And so, but if you had to write that down everywhere, you take up a lot of space
Sure.
to write down everything we just said out loud.
Yeah.
So you might want to go smaller than that. Like if your whole business, your whole database only deals with a certain one time zone.
Yeah.
Like for example, we're in the Pacific time zone. That's currently -7, sometimes -8.
Daylight savings.
Yep, that depends what shifts. But and if we just ignore that and you just write the time as of the time you get it, you can use something called datetime 2. That's the year, month, day, hours, minutes, seconds, and 7 decimal places.
Decimal, not float.
Yes, decimal places. They're fixed right there. They're not floating off. And that's datetime 2. But you're like, oh, but that's a lot of space. Maybe I don't need 7. Maybe I only need 3.
Sure.
So you can go smaller. You can just go datetime.
Daytime.
Like a regular datetime uses less space. You don't have to worry about those extra decimals.
Yeah.
So it's 2026, January 1st, 13:30, 00 seconds, 0.123. I think that's milliseconds. And maybe you don't need the milliseconds. You just need up to the seconds. So there's something called small datetime. Again, less space, less precision.
Yeah.
And then the small datetime can be broken up into 2 components.
Okay.
It's called small date time, and if you break it up, you have the date and time. Yeah, and the time is that small piece, just the 13:30:00.
Yeah.
So 1:30 p.m. 00 seconds.
Yeah.
That's the time component, and then the date, year, month, day.
And I guess it just depends on what you need the data for.
Yes, exactly. It's all measuring buckets. It's all your parking lot size, your queue size. It's all the same concept. The data type is a data container, and you want the right to-go container, the right data container for the right data. If you're only storing dates, then you don't need datetime offset.
Yeah, because it's a lot of extra for nothing.
A lot of extra space. You just store a date. Yeah.
Versus if you're using, if you're saying a log or some sort of process that needs to keep track of very precise times so that it doesn't like overlap with anything else, then you need to go a little bit more in depth.
Right.
Then maybe daytime offset might be, or datetime 2 might be the more optimal data types.
Being that we're a very globally connected world now, meetings that are scheduled, you need to know when they say 1 p.m., they meant 1 p.m. their time. And what does that mean for you?
Right.
So the datetime offset information needs to be carried. That's very important in a globally connected world. And globally connected logs from different servers. You don't know when, where it came in. 1 p.m. to you is different than 1 p.m. to them.
Yes.
So if you carry the information, you can adjust.
Yeah, because if you're trying to debug something and someone says, oh, it happened at 1 p.m., but it's like 1 p.m. in like East Coast.
And so you got to be looking at your logs at 10 a.m.
Yeah.
Yeah.
Or it depends on the daylight savings, but
No.
Oh, wait,
It's always
I don't
3
know
hours
why.
difference.
It's always 3 hours. I don't know what I'm talking about. Just daytime is messing with me.
Yep, because there's a lot. But really, it's just what bucket size you need.
Yeah. Okay. Look, now let's talk about something completely different.
Oh,
something
no.
we haven't talked about is basically shapes.
Shapes.
Yes.
Oh, okay.
Yeah. So, how do we store shapes?
So, how we store is the format. And so you hear of terms like well-known text format, GeoJSON, and different systems store it differently. But they all revolve around the same concept, which is storing a point, a line, or a polygon.
Okay.
So if you have one dot, that's a point.
Yeah.
Some point on Earth.
Yeah. Like a lat long.
Like a latitude, longitude. And then, which I think we covered in a different GIS episode.
Yes.
And 2 points make a line. So you connect those 2 points together.
Yep.
And then a series of points that do not close in on itself is like a road, right? Like a line string.
Yeah.
But if you have at least 3 points that close in on each other, and you can have more, it becomes a polygon. So you can have a triangle, right? A quadrilateral, pentagon.
Excuse me.
It can. You good? So different. All the points together, you can form like a shape.
Okay.
Any kind of shape.
Yeah.
But the key thing to note is that different systems treat geometry differently than geography.
So let's talk about that.
Okay.
What is geometry versus geography?
Okay. Have you taken a geometry class?
Yeah. In high school.
Yeah. So that's something they use a Euclidean plane or a Cartesian plane. It's just flat on a piece of graph paper on a flat surface. You have your origin point 0, 0, and you have all your other points you can draw lines and connect.
Yeah, yeah.
And that's just flat. But if you drape that piece of paper over the globe, that's geography. It takes into account the curvature of the Earth, depending on what latitude you're at, where you are on Earth.
Sure.
So a straight line, the shortest distance between 2 points on a flat paper is just a straight line.
Yeah.
But on the Earth, over a globe, it's not necessarily true.
It's like how planes fly.
Yes, you have to follow something called the Great Circle over the Earth. You have to take a certain path to get the shortest along the curvature of the Earth.
Yeah.
So there's math about that, and that's geography.
That's why when you fly and you look at those maps, like flight tracker or whatever, right? You're like, why are we going so around? Like, why are we going so north or so south? You're not actually, because that's just how it looks on a 2D TV.
Yes, a screen. But basically, if you think about it, that curve, it intersects the center of the Earth, and if you follow on that line. You take your origin and your destination point, trace a line that's on the arc of a circle cutting through the center of the Earth. That's called the Great Circle. That's the shortest path.
Yeah.
But when you when you deal with latitude, longitudes, you have to use geography type.
Okay.
Because it accounts for all this.
Okay.
Yeah. And so obviously, if you need to store points, lines, and polygons, you have to use the right geotype.
Sure. Yeah. Huh. All right. That was a lot of data types.
Hey, but they matter. All data types matter.
They do.
And because again, I can't stress enough, using the right data type for your right data, the container, will help self-validate your data.
Yeah.
You wanted something to store polygons, and someone's trying to insert the number 1.
Yeah.
You're like, this is
not
right.
gonna work.
Not gonna work.
Yeah. And it's also to protect you from, not protect you, but protect your data so that when you are exporting or sending it to someone else, that they are also receiving it the way you're intending them to.
That's right. That's right. Yeah, you tell someone this is a decimal field, then they do the same and they can get it in the right way.
Yep. Keeps everybody happy. Awesome. Well, I think that was what we had for today. I think, sorry, I'm like, I'm still in the data type mindset right now. But if you like this type of content, make sure you click like and subscribe so we can reach more viewers like yourself, and then you'll also be notified when we have new videos up.
We'd love to hear from you, so email us at podcast@melissa.com. Find us on LinkedIn or leave a review below.
All right. Well, until next time.
Stay data curious.